The Uncle Gold Podcast.
Like a countdown for a rocket. So 5, 4, 3, 2, 1. And welcome everybody to the Uncle Gold Podcast. My name is Borna Zuber, and as most of you probably didn't have the rich uncle who taught you how to get the gold in life, but that is the reason why we started this podcast. And the idea is to bring a lot of people who have interesting ideas, who can talk about really cool topics that can impact your life. And today I have a special guest on. He's my dear friend. We work together. Today we have Brendan Caulfield here with us. Brendan, welcome to the Uncle Gold Podcast.
Hey, thanks very much, Borna, Uncle Gold. It's great to be here, and it's an honor to be asked. So thanks.
Yeah, I was looking forward to doing a podcast with you. We already did a video beforehand, and I would like to touch on that a little bit. But I think that generally technology is a place where a lot of people will find success in life, and it will have a huge impact on people's lives. And I know that you're a huge fan of technologies, of stuff that's going on in the world, and especially space. We're going into the
stuff that's going on outside the world as well.
Yeah, exactly. And the world seems to be moving in a new frontier. But
Sure.
Before we go into space and all of that, for the audience, can you tell us a little bit about yourself, who you are, and how we met, and how this whole journey kind of started?
Yeah, sure. So I'm Brendan. I'm from Dublin, living in the Kerry region of Ireland, which is where I've met Borna. We met because I got a job in his company, and we were working together. So it was, I think we really hit it off like pretty much from moment number one, and just kindred spirits and that. So yeah, and I'm here because of my interest in space and astronomy and technology, and also on the down to earth side of things, renewable energy, electric vehicles, just sort of cutting edge technologies. Before the show, we were talking a little bit about the fact that I just got a 3D printer. So all those kinds of funky, cool, sexy kind of technologies these days.
Yeah.
So
I agree. We really did start this whole journey like in a fun way, and it was really cool working with you, man. But today we're gonna focus a little bit more on not work related stuff. I want to start with just regular Tesla and Elon Musk,
Sure.
because that's something where we kind of first started talking more about technology, and then we'll go into space and SpaceX a little bit. Tell me, let's go with first-hand experience. You drove
Sure.
a Tesla yourself. What's the
Yeah.
difference between a normal car and like a Tesla car?
Oh, well, I mean, there's the obvious stuff. It's super quiet, but there's the less obvious stuff and the things that really surprised me. So just to clarify, I drove a Model S back in 2015. It was kind of a birthday present. My sister lives in Norway. She invited me over and organized a test drive.
Mm-hmm.
And they were really cool. They weren't pushy about, buying the car or anything. It was more about getting the word of mouth out there. So I'm kind of doing the job they wanted me to do by talking about it. But yeah, one of the things that first strikes you when you get into one of these cars is when you want to start moving, there's very little to actually do. You don't have to press a button or turn anything on. The fact that you're in the car alerts the car that it's time to go. Like you have the app on your phone, or you have the key fob in your pocket, or whatever. It's keyless entry. That's fairly standard, but there's no kajunk. There's no shake of the car. There's nothing. You just gently put your foot on the pedal, and it starts to move quiet as a whisper. And it's that initial motion that really like blew my mind, because it's just, it feels like you're just almost sliding away on ice, but under control. It's a really, really nice little feeling. And then of course you get out on the open road and you put the foot down and it just jumps to warp speed. It's the response time of pushing the pedal down is almost as if it responds before you put your foot down. It's so instant. I didn't realize it, but from driving fossil fuel cars, I was used to a bit of lag time. It was just how the thing worked. But you put your foot down in an electric car and it's just there. It's instant. And that acceleration is a smooth curve. There's no changing between gears. There's no shuddering, no shaking. Everything is so smooth and so nice and comfortable, and very quiet as well. So yeah, that first test drive, the first taste of the acceleration that I got was that we were on the highway and I was going to overtake a slow car in front, and I checked in front, of course, checked the mirrors, and then I looked over my shoulder, saw it was clear, and I started to apply pressure on the pedal. And in the time it took me to do the motion from looking over my shoulder to looking ahead again, maybe a quarter of a second, it had accelerated by like 25 kilometers per hour. And I wasn't even putting full pressure on it. It was kind of, whoa, okay, this thing moves. But yeah, they're so beautiful to drive.
I heard that a lot of people still perceive electric cars as Priuses and these old kind of like hybrid cars, but everybody who drove a Tesla actually says that it's a completely different thing. It's not a hybrid. It's not something that's like an old model of car that literally redesign how a car works. And I heard, I think it was Joe Rogan and someone saying online, he compared it to the small, like electric toys that people have to, that they had it on the remote control, and the acceleration kind of felt like that, where literally
there is
felt like a rocket.
It sounds wrong to say it like this, but there is a kind of an element of the go-kart to it, in that it seems like the car is getting out from under you. But at the same time, that sounds like there's a lack of control, but you feel like you have exceptional control, because as soon as you get anyway uncomfortable and your foot lifts off the accelerator just a tiny amount, you feel that change. And not in a lurchy kind of way. All of the, like, if you're to graph out the curves of acceleration and change in acceleration, everything is smooth. There's no jerking around, and that's really what struck me when I finished the test drive. I got back into a fossil fuel car to go home, and as soon as the key turned in the ignition, the whole car shook, and there's just like jerks and shakes and vibrations that you are just completely unaware of until you've driven a Tesla. Then you get back in a regular car and it's like, whoa, this thing feels like a medieval contraption by comparison.
In spite of the serious in favor of the serious acceleration speeds, Tesla puts a lot of emphasis on making the car really secure. I heard that they do a lot of testing, and like that they passed all security tests with flying colors, and that not only is it the best electric car, it's kind of the safest car out there. Did I understand that correctly?
Yeah, right from the beginning, like back in 2013 when the Model S, I think it was 2013, when the Model S was being rolled out, and they were getting their Euro NCAP safety tests done, and the US equivalent. I remember there was a story about I think it was the US test, and they were doing a crush test where they basically put the car in a gigantic hydraulic vise and see how much pressure it can take. And the machine got up to a pressure equivalent to 5 other Tesla Model S stacked on top, and then the machine broke. So the car refused to crush, and this is an aluminium bodied car. It's like, you don't think of aluminium as a strong material, but the way that they have it molded and built is just exceptionally strong. But at the same time, of course, it has to crush in certain directions to absorb the impact. So ahead of the passenger cabin in a standard car, what do you have? Directly in front of the driver, you have a big block of metal, a big engine. And if you impact another vehicle, that big block is not going to crush. It's going to come through the cabin and crush your legs. And in the Tesla, there's nothing ahead of the driver. There's a frunk, as they call it, a front trunk. It's just empty space, and you can put luggage in there and stuff, but they have crush zones all around that. So the passenger cab is far safer in an electric car than it would be a standard combustion car, internal combustion engine car.
Tesla has everything underneath, right? On the lower section. right?
That's right. Yeah. So they had the wheels and the axles sort of define the edges of what they call the skateboard, and that is entirely composed of the batteries.
Mm-hmm.
So I don't know. Maybe we didn't mention that Tesla is an electric car company, or a car through and through. Electric motors, electric batteries. There isn't an ounce of combusting oil in this thing. Yeah. So the whole car is sitting on this skateboard, and then the structure of the car is built around that. So there's inherently greater safety in that. In that there's a lot of mass in those batteries, so that brings the center of gravity of the car down lower. That improves your handling, your road holding, and so on. But it also means that you're less likely to roll the car. So there's a number of different models of Tesla. There's Model S, which is the first one I drove. There's Model X, which is the sort of larger, almost SUV type vehicle.
Mm-hmm.
That's reasonably tall, and and historically, stuff like the Mercedes A-Class back in the early 2000s, they had issues with these tall cars that they would roll too easily. And I remember there was a recall for that. But with the center of gravity centered on the battery pack, the taller Teslas, they road hold just as well as the shorter ones.
Awesome stuff.
But I should also emphasize that there's some inherent benefits to an electric vehicle in terms of safety and road holding and all of that, but they go above and beyond in every aspect of the car. There's full airbag layouts inside. There's great seat belts and brakes, and then of course there's the active systems. So the car is watching the road for you, and if it sees something up ahead, and it's got a suite of sensors including radar and stuff that can actually bounce off the road and detect cars 2 and 3 vehicles ahead.
Nice.
And if you look for YouTube videos of Tesla saves my life or something like that, you'll see numerous instances where someone has their dash cam on, they're driving along, an alarm goes off in the car, and the car actually brakes and pulls over to the side of the road on its own.
Really?
And in a split second, the driver and the passengers will be going, "What the hell? Why is it doing this?" Or expressing something like that. But in the foreground or in the distance, 2 or 3 cars ahead, a car crashes. And the Tesla AI spotted that and then reacted to it. So yeah, I was talking about how so if you search on YouTube for Tesla Saved My Life, you'll find a lot of videos where it'll be a dash cam video, people will be driving along. Suddenly the car will start beeping, as in like an alarm inside the car, beep, beep, beep. And then it'll brake and pull over to the side of the road. And the sensors on the car have detected, either through the camera vision or through radar that bounces off the road and detects multiple cars ahead, that there was a bad situation evolving. And it was able to sort of project forward what that was going to result in, high probability of a crash. So it took over, slowed you down, pulled you over to the side of the road.
Sounds awesome.
Yeah, it's pretty incredible. I haven't seen too many false positives of that, which is the even more amazing thing, because it's predicting what's going to happen and reacting to it before it happens. Just stunning. And that's all technology that's involved, of course, in the self-driving and all of that I can do, which we can talk about as well.
Let's go into the story about AI and self-driving cars. You started there on the topic.
Yeah, sure. So yeah, I mean, all of the crash safety systems and are, I guess they're stablemates, if not developed from, but certainly using the same technology and the same sort of theory as the self-driving systems. So it was a goal from very early on in at least the Model S program, if not from the beginning of Tesla itself, to make the cars able to drive whole journeys. They're not quite, 100% at that point yet. It has taken a lot longer than they expected, but it is the case that certainly if your destination is, if you're living in the US, for example, and your destination is on the other end of a highway system, you can tell the car what your destination is, and it will drive the route for you, including changing lanes, taking exits, negotiating junctions, and getting onto other highways. it's not legal for city streets and urban environments to drive around it, as far as I'm aware yet.
Hmm.
But I think it's probably capable of that at this point. And a lot of people are using it, as in, when I say it's not legal to use that system unsupervised in those environments, but it is absolutely legal as long as you're keeping attention, and the car will alert you if you haven't touched the steering wheel in the last minute or so. It will start dinging at you, and if you don't respond, it'll slow down, pull over, and turn on the hazard lights. So it's like it's kind of smart in that way.
Cool.
But the whole thing is based on hoovering up huge amounts of data from all the different cars, processing it, and an AI algorithm that is learning to understand what it sees. So it's chiefly working with camera systems, vision-based navigation at the moment. They have done radar systems. I think the cars are still equipped with radar systems, but they're finding that as they develop these systems, actually emulating the way that humans understand the world is working best for the AI. So it's reading road signs, it's understanding where the lines on the road are. And even when it drives on an unmarked road, it'll actually map out, if you get into the developer mode on the car, and it will annotate everything that it's seeing in the camera view. It'll actually map out where the road lines should be if the road were marked properly. Nice. And sort of adhere to those. So it's doing what we unconsciously do, and it's still learning. It's not 100% perfect, but it is, statistically speaking, already safer than a human driver driving the car.
Awesome.
Of course, anytime, there's that 1 in a million chance of an accident, anytime there is an accident with the system on, it gets massive media coverage, but that's just the nature of media.
That's how it works. Do you think that in a few years we will be all driving, well, not driving anymore?
I think that there will be people who drive because they're driving enthusiasts. They enjoy the thrill of driving, volume as well, and also discharging that energy faster, because the acceleration of the vehicle, of course, is a function of how fast can you get the energy out of the battery and into the motors. And also, of course, you want high volume so that you can store lots of energy, so you can accelerate lots of times. Mm-hmm. And even if you don't want to accelerate super fast but want to travel long range, obviously you need to store a lot of energy, and to do it also from a safety perspective in a non-volatile way, so that if the battery compartment gets pierced, it doesn't cause a fire or destruction of the car in any way. Because you're basically bottling up a lot of energy in a small space, and that's always going to result in some fireworks in some way. Mm-hmm. So not only have they been advancing the chemistry and doing lots of internal research, they've also been sort of shopping around and buying up smaller companies that have interesting technology. And one of the leaders in sort of battery chemistry research was Maxwell. I think it's Maxwell Technologies. They bought that company last year, and there's an announcement coming up which has been postponed because of the coronavirus, called Battery Day. They've just been referring to this as Battery Day for like a year and a half at this point, and teasing as to what that's going to involve. Some hints came out recently about the new form factor for new battery cells that they'll be switching to. So they're basically setting their own standard as opposed to using industry standards that they have been using up to this point. And there's been some rumors that the battery chemistry could yield as much as a 5 times increase in the amount of energy that you can store in a particular space.
Wow.
Which means cheaper to produce, much longer range vehicles. So hopefully that means that we get things like their lower price model, the Model 3, getting down under 30,000, maybe 20,000 US dollars to sell domestically anyway. And when the factory in Europe is up and running,
that would be brilliant. Yeah,
absolutely. Yeah. Now, all the focus on Tesla, we've kind of been ignoring other brands, and it should be noted that there are really competent electric cars out there that are really very cool, and they are approaching that price point now as well. You've got the likes of the Renault Zoe, for example, the latest version of which I think is really, really nice. I wouldn't have been all that interested in previous versions, but now they've got great range, really good style, and a very comfortable kind of interior. And that's like sub 30 grand. I think it's 26 it starts at. But so, that's one of the wider effects of everything that Tesla's been doing, is that the whole market is reacting to this.
Yeah.
They're leading the charge, and other car companies are being forced to follow.
Yeah. I love that their concept is basically have all their patents open and not hiding, but the idea of sharing it with everyone. First of all, it's such a genius move where you don't have that like corporate espionage and all of that where people are stealing, where you basically say, look, we did this, let's just make it better for the whole of humanity, right? And then the whole industry of car producing, manufacturing, driving, using cars gets better with time, and I think that'll just result in a better result for them in the end.
Indeed, and that's sort of emblematic of the culture of the company. It wasn't founded exclusively to make a whole boatload of money. It was founded to accelerate the transition to sustainable energy and non-polluting transportation technologies, and not just by dominating the market in a monopoly, because that's not realistic, but by creating the technologies and leading the charge, as they have been doing. It is paying off now. This vision is coming to fruition. They're showing how it should be done, and other companies are actually following along. So they're creating the market. And every time a company comes out and says, our vehicle is gonna, it's the Tesla killer. There was just a rake of people talking about having Tesla killers for years there, and none of them ever did. They could never touch a Tesla. Very recently, there's an exciting new vehicle that actually might. But every time someone would come out and make that kind of claim, Elon Musk would go, cool, do it. Let's see it. Because that's his aim. It's not to dominate. He's just dominating because they are the best. But it's to create that new world, to push it forward and get us over that line. Because really what's motivating all of this is the fear of catastrophic climate change. And realizing that nobody is addressing it at the levels that it needs to be addressed. That's not to say that Tesla is a silver bullet, but it's a massive step in the right direction, and it's really pulling the rest of the world along.
I know they've been involved in experimenting with city batteries, not just car batteries. I think it was in Australia where they're testing it out, and they're getting really, really great results. Can you tell us a little bit more about that?
Sure, yeah. So I think it's New South Wales. They had this, 70 megawatt hour battery installation, something like that. I'm usually wrong on my numbers. But the reason for that was that, first off, in Australia, the electricity market was crazy expensive. People were having to choose between, people on not really low incomes were having to choose between doing the shopping or paying for the electricity. There were rolling blackouts and brownouts because the infrastructure that was over there was based on coal power plants and then gas powered relief stations. So if there was a blackout from a coal power, they'd spin up a gas plant to fill that need in the market. But a gas plant takes time to spin up. And so you get brownouts in between times, get blackouts. Sometimes the grid would fail because of surges associated with all of that. So you had all sorts of issues, which ended with a human cost. There were people, in some cases, losing their livelihoods because of this. And so it became a political issue. There was a lot of talk on Twitter about it. And someone who had Elon Musk's ear on Twitter, as someone who he might have responded to on occasion, said, "Hey, Elon, you're building these batteries, these big power plants. They had announced the idea of these power pack units that you could just slot into place, have an array of them, and have backup for your building or your campus or small town. And he sort of challenged Musk to do this. And Elon came back and says, "Yeah, okay, we'll have it ready by Christmas, and if it's not, we'll do it for free." So sure enough, he did it. It was ready by Christmas. And when they brought it online, the first time it was sort of called into action in that sort of relief mode where it makes up for a drop in power, it came up to full strength in a quarter of a second. 70 megawatts provided to the grid within a quarter of a second of the failure of the coal plant that it was relieved.
Nice.
There's islands in the Pacific that are completely powered now by solar plants and a power pack array. And that means they don't need to get fossil fuels delivered on a weekly basis in expensive freighters and then burn that in polluting generator systems. And it's a really, really nice solution. So I expect to see those popping up in a lot of places. And one of the things actually that could come out of Battery Day is if the energy density, the power per unit of volume comes down, and that brings the price down, we could see home storage becoming extremely affordable, because Tesla already does a version of the power pack called the Powerwall for home energy storage, and that's like maybe a 1/5 of a Model S battery that can back up the power that you would need to run your house for like 3 or 4 days.
Nice.
You have a solar power system, then you charge during the day, you draw from this during the night, and you're sorted. But they cost, I think, 20 grand for a Powerwall. If they can bring that price down to like 4 grand, then that starts to be a standard utility that you install in a house when you're building it.
That would be awesome. I saw the presentation where he unveiled the Tesla battery that's hooked up to your house, and the solar panels that are basically the roof plating. So you're kind of have like really scalable stuff. Like it's a lot harder than normal. Like what was it? Like
the roof tiles.
Yeah, it was like 2 or 3 times harder, resistant to heat, water. Like you have to change them every like 20, 30 years, like, so it really seems like a good package, and he's put in a lot of effort into kind of like thinking through how it can be useful. And I think with time we'll see the prices go down a lot, and I think we'll just go to mass adoption.
The tiles that you're talking about, they're designed to be seamless and look like just natural, or not natural, but like, normal roof tiles. So you'd look at a house that's completely covered in solar panels and you wouldn't see a single solar panel. And the aim with those was to have the price of installation for that be less than a standard roof, which is great if you're building a house, because you can build this into a house and actually save money by doing it, and save money later on because you're generating your own power. And they're actually already at that point. So in the States where they're installing these roofs, you can do that now. But of course, if you want it for an existing house, it means basically replacing your roof, which doesn't get pricey.
So it will be right now applicable more to new houses. All right. Well, we'll get there. Fun question. Do you think that Tesla will be the first company to build a Dyson sphere?
Oh, okay. I think a Dyson sphere is generations away at best. I kind of wouldn't. So this gets into the whole cosmology thing, but a Dyson sphere, to explain, I suppose, for people who may not know what we're talking about, is a structure that surrounds a sun-like star in a sphere at the distance from with the radius of the Earth's orbit around the sun. So you can then line the interior with essentially an Earth-like environment, and you have energy coming from the star that you can collect from every angle. that is an insane concept to think about. But it is something that we kind of expect that like maybe a version of humanity that's 1,000 years more advanced, or perhaps even less, maybe 400 or 500 years, could be able to construct. And so it's one of the sort of markers that we look for when we're looking out into the cosmos, trying to find the alien civilizations, is can we spot the telltale of a Dyson sphere? Because even though it's an enormous, unimaginably enormous structure, at the distances that we are from other stars, we really wouldn't be able to see it. And because it would be blocking out a star, it would be effectively invisible.
Yeah,
but
a black point.
Yeah, the against a black sky, so a little bit hard to spot. But the in other wavelengths like the infrared, all of that energy that's getting absorbed by the Dyson sphere would have to be radiated out in some way on wavelengths that they're not using. So it's expected that they would be quite bright in the infrared, and so far nothing like that has been detected. So it's sort of one of those questions of why aren't we seeing those? Shouldn't those happen? So I tend to think that maybe there's some other avenue of development that life will just sort of naturally fork off onto instead of doing Dyson spheres. They may just be more trouble than they're worth. But I mean, if there was any company or collection of companies, because I expect it to be a massive merger or conglomeration of different companies, SpaceX, Tesla, and whoever else follow in their footsteps as the trailblazers of the future would certainly be the people to do it.
Looking at the Dyson sphere concept, like when you look at solar panels on your roof, you get a bunch of energy, right, throughout the year. When it's sunny in a sunny region, like it's a ridiculously small area and you still get a lot of energy out of it.
Yeah.
A Dyson sphere is a ridiculously large area, and the energy created there will be almost limitless, right?
Yeah. You're essentially capturing all of the energy coming out of the sun.
Yeah, and the sun like goes for a few 100 million or billion years.
Yeah.
So it's, let's say, unlimited energy. What could we do with unlimited energy?
Oh God. Okay, we're getting into crazy territory here. I mean, unlimited energy. Obviously, when you've got the technology to build a Dyson sphere, and I think sphere is a slight misnomer because generally speaking, you're probably going to. So a sphere as a solid structure surrounding a star, I think is probably impossible, because to get the purity of material required to hold that structure up against any kind of gravitational distortions, either caused by mass variations in the star, or potentially, if you don't pulverize all of the planets in the solar system to make this thing, there might be planets or objects orbiting the sun, and you get tiny little variations in gravity that I think would tend to warp and distort the structure of the thing. And you'd also need it to be extremely thick so that when you're on the inside surface, there's enough mass below you to actually gravitate you towards the surface rather than just falling inwards towards
into the sun.
Yeah. So it requires an absolutely gargantuan amount of material, almost certainly more. Definitely more material than exists in the solar system. So you would be raiding neighboring stars to bring in material for it. So I think
what you have to deconstruct planets for that, right? Like
100%. Yeah. That's like a prerequisite. So I think what is more likely is a Dyson swarm, which is a huge cloud of satellites that orbit. And you could get it to be close to a sphere by just having them at slightly different distances from the star, such that they occlude one another and slide past. So you could have large surface areas, like larger than the Earth, larger than the surface area of the Earth, if you wanted to. And that could potentially be done. Again, we're talking about deconstructing planets to make these stuff. On the more conservative scale, you might have a Dyson swarm of simply solar collectors that collect power. They're very thin, mylar-like material that can centralize the power, and then that's beamed with, I don't know, lasers or something to a central collection point. And that way you're harvesting the energy of the star, but you might actually still live on planets or in smaller space colonies. And that's probably the nearer term, more practical, more realistic one. Still probably a couple of 100 years away. But what could you do with that power? At any of those scales, you've got extremely advanced technology. So you could do so many different things, but in terms of cosmic exploration, with existing technology, you could power an enormous laser that would push a light sail spacecraft up to relativistic velocities. So this is speeds close to the speed of light, or at least some appreciable chunk of the speed of light. You could send a colony ship to another star. You could, that kind of thing. With technologies that we really don't have a clue how we could possibly build them yet. But with those kinds of energy levels, you could maybe create wormholes. You might be able to do some really funky stuff with space-time and dark matter, and maybe circumvent the speed of light as a speed limit for the universe. I'm fervently hopeful that we'll find that loophole some way, a warp drive or a wormhole or something, and be able to explore within our human lifetimes. But at that point, what does a human lifetime mean? Because we're likely to be completely melded with machine at that point.
Yeah, probably. All right. I have a question on the levels of civilizations, just to give a perspective to people listening. There was a book written that outlines like how a civilization evolves, and we're not at the further points on 2 or 3 or what was it?
No,
I don't.
We're not even at 1.
Can you give an outline on that and kind of scale it back to where we are?
Sure. You're talking about the Karaschev scale. So this is the sort of from the cosmic perspective, this is the ranking system for the development of a civilization. So it's basically, it ties in neatly with the Dyson sphere idea, because it rates a civilization based on power consumption or power utilization. So a Kardashev level 1 civilization is a civilization that has been able to efficiently collect all of the energy available on their home planet. So we're not at that level yet. We're not anywhere near efficiently collecting all of the energy that's available to us here. It's a logarithmic scale though, so we're close to 1 in numerical terms, but
is there like
really
an estimate on 0 point how much?
We're at 0.7, which sounds much closer to 1 than we actually are, because it is a logarithmic scale. So there's a lot of, yeah, exactly. It's a curve that just keeps bending upwards. So 0.7 is where we're at as far as most of the estimates go right now. 1.0 might be possible within the next century and a half. And then when you get to Kardashev level 2 civilizations, those are civilizations that can harvest all of the energy that's available to them from their star. So that's Dyson sphere level tech. And then Kardashev level 3 is all of the energy from their home galaxy. So they have Dyson sphered every star in their galaxy. And then Kardashev level 4 would be multiple galaxies, so whole galactic clusters that are colonized in this way. But you're talking about, particularly if we can't break the speed of light, if that is an absolute speed limit, we're talking about tens of millions of years or hundreds of millions of years to get to Kardashev level 4. But and like I say, I suspect that there's probably some fork in the road that we're not even aware of. In the Middle Ages, who could have, well, maybe not Middle Ages, but in the distant past, who could have predicted electricity and the impact that would have on our lives? That's magic as far as they're concerned.
Unfathomable. All right, let's scale it back down to where we are right now. So the first step that we actually need to take is getting from one planet to a second planet. We managed to do that in the last century. Like, a few times. There have been a number of spacewalks and a few people that been on the moon. And now in this century, we're trying to do it like something like a tourist tour that you could do a lot, actually, not just once or twice or a few times, but actually that can be a regular thing for people to go from one planet to the other. Let's go into that as the final phase of this podcast. I would really want to learn more about that, and I know that this will be very interesting to people.
Yeah, sure. So, I mean, yeah, when you say we've gone to another planet in the last century, we've gone to our own moon in terms of human beings. We've made our presence known, if there's anyone there to know it, on other planets by dropping probes on them. So we've put probes on pretty much every solid planet in our solar system, and that's great and all. But I would really like to go there myself and feel the grit crunch under my boots as I walk around, and know that where I put my foot is the first time anyone's ever put their foot in that particular spot. So yeah, there's a great draw of exploration that I feel, and now is the most exciting time in half a century to feel that draw, particularly in regards to space. So I mean, the conversation keeps revolving around Elon Musk. Another of his companies is SpaceX, and that was founded because back in the early 2000s, he had just made a bunch of money by founding what would become PayPal, and then getting drummed out of that because his ambitions were too big, and given a golden handshake. And so he, back in college, he had been looking at like, what are the existential threats to humanity? What could wipe us out? Or what is a problem that we need to overcome? So he identified a list of them. I can never remember all of them, but there was stuff like the rise of AI would be a major threat if we can't understand what its motivations are. So he figured that would be something that we'd need to do something about. Climate change, of course, and that led to his involvement with Tesla, and becoming a multiplanetary species, because there's a great quote, and I wish I could remember who to attribute it to, but it may have been Carl Sagan, but it goes something along the lines of: the cosmos is likely littered with the single planet graves of civilizations who thought that space exploration shouldn't be a priority. And so if you keep your species on one planet, then it is vulnerable. You literally have all of your eggs in one basket. And if anything happens to that planet, that's the end of your civilization. And as I said before, when we were talking about Dyson spheres, we've been looking for signs of other civilizations out there in the cosmos, and we haven't seen anything definitive. So as far as we're aware, our intelligence is the only intelligence in the universe. And our intelligence is something that has sprung forth from the natural evolution of the physical matter of reality. So we are made of the universe. We are made of the matter that has been recycled down through the eons, through stars that have formed, lived out their lives, and exploded and enriched the galaxy with additional elements. And that has come together to make us. We're made of that stuff. And there's kind of a spiritual element to this feeling of we are the universe, and we're the only way that the universe has to understand itself. And if that's the case, I kind of feel like it's incumbent upon us to preserve that intelligence. And so keeping all of this intelligence on one vulnerable planet is not the best idea in the world.
Yeah.
So that's
Agreed.
the angle that Musk came at it from. Yeah. That was a bit long-winded way of putting it, but essentially he decided that one of these potential extinction factors would be something happening to Earth, be it plague, asteroid impact, coronal mass ejection from the sun, gamma ray burst from the star. Something can kill all of humanity if it destroys the Earth. So we need to be establishing off-world colonies. backups for this biosphere. And he went and had when the PayPal thing happened, he went and had a look at the NASA website to see what the plans were for colonizing Mars, and he couldn't find anything. And he was shocked by this. So he decided that he would like to do some kind of action with the money that he had that would spur the public into thinking about that and hopefully electing people who would make that happen. But long story short, he had an awful lot of trouble trying to make that happen and realized that one of the major issues is that it's extremely expensive to get into space.
Mm-hmm.
And so he decided that he would just do that himself. And if he was going to do that himself, he might as well aim for the end goal, which is multi-planetary civilization.
Why not?
Yeah,
right?
Just like we all would.
It's like sitting in your dorm room and like, I'm gonna go to Mars.
Yeah, I'm frustrated with NASA not doing it, so why don't I do it? There's an incredible level of hubris there, and
yeah,
that's sort of what I admire about the guy, is that he does not seem to have this kind of I shouldn't be doing this kind of attitude. He just says, I can do this, so why shouldn't I? Or I may not be able to, but I'm goddamn well going to try. So so SpaceX was founded in 2002. They launched 3 little rockets for customers between 2006 and 2008. They all failed. One of the payloads, one of the satellites that they were launching, when the rocket exploded under it, the satellite actually fell directly back down into its own shipping crate at the launch site. But their 4th launch, when they had basically no money left, was a success, and then they managed to get a NASA contract for resupplying the space station. By that point, they had plans for a larger rocket. That became the Falcon 9. That first launched in 2010, I think. Yeah. They first sent resupply to the station in 2012 on a Falcon 9 rocket. And then over the following few years, the Falcon 9 became the workhorse of the launch industry. They were initially seen as scrappy upstarts. People didn't know anything about what they were doing. Private company attempting to play with the big boys, and then they very quickly schooled the big boys in how you actually do this thing and do it economically. Falcon 9 costs completely expendable, so like throwing every part of it away, you can get a Falcon 9 launch for I think $62 million. The next most comparable rocket from another supplier would be around the $400 million mark.
Wow, so it's a fraction of a price.
Yeah, an absolute fraction. And they're working on getting that down further, because one of the technologies that Musk realized is an absolute requirement for actually mounting a program as complex as going to Mars and colonizing, is that you can't throw your rockets away with every launch. So if you think about the sort of cliche or overused footage that anytime anybody wants to show a rocket launch, they always show that image of the pieces breaking off the rocket and then separating and engines lighting up. That's because you don't want to be hauling empty tanks with you, so you separate them off. You don't want to be hauling the big powerful engines that get you off the ground with you, so you separate them off. Historically, those would just fall in the ocean and smash, or if you're Chinese, fall on villages. They do that a lot, unfortunately. But the key technology then is to have they're vehicles with engines on them. So just have them light up the engine and fly home. And it sounds so simple, but it's an incredibly complex thing. And pretty much every rocket scientist in the world back in the early 2010s was looking at this going, this is absurd. This is a stupid idea. It cannot work. You can't do this. And SpaceX just forged ahead. They kept doing tests over the ocean where they would drop the first stage down and then light up the engines. Early on, nothing was happening. They tried with parachutes initially. The parachutes would just shred. It's insanely difficult thing to do because the forces involved are crazy. And then in 2014, they started actually managing to get the rocket to survive down to the ocean surface and actually fire its engines while pointing the correct direction and land like nothing else does.
Yeah.
It's like
Those
a
are the
pen.
videos that we saw where it lands like completely
Yeah.
straight back onto a small, like a landing pad.
Yeah, exactly. So they didn't get the landing pad part working until mid 2016, but in 2014 they were just sort of we're getting grainy footage from very far away of this rocket hovering over the water, and it was so exciting to follow. And then they had a launch failure, which sort of put everyone's heart in their mouth. One of the resupply rockets to the space station blew up shortly after launch, and that could have cost them the company at that point. It was at a point in their history where they were very vulnerable, and it took 6 months for them to identify the cause and correct for it, which was a really fun and interesting story. But I don't want to get bogged down in that. But when they returned to flight, then on the 21st of December 2015, it was with a really ambitious mission. They were launching a satellite for the Orbcomm company. And all of their previous landing attempts had been out at sea. They had, as you said, they had built this drone ship, this landing platform that could station keep out in the middle of the ocean, and they kept trying to land on that. It would come down and something would go wrong. Either they'd run out of hydraulic fluid, or it would have slightly stuck valve in an engine or something, and the rocket would always smash into the ocean nearby or hit the deck of the drone ship. One of them even punched a hole in the drone ship's deck. It's pretty spectacular. They released this wonderful video called How Not to Land an Orbital Class Rocket, which is just explosion after explosion after explosion set to the theme to Monty Python. And it's fantastic. But on the 21st of December, they said, we're going to launch this Orbcomm satellite. We're going to land the rocket back at a landing pad just down the road from the launch pad. And everybody thought they were nuts. And then 8 minutes into flight, that rocket descended over Florida, lit up the night sky with an orange glow, and touched down softly on the landing pad. And I was watching that at like 4 a.m. in the morning in the middle of rural Ireland. And I screamed and danced and laughed and nearly passed out just from absolute euphoria, because this was just an impossibility, an incredible technological achievement, but it also validated the aim of the company, which is to make rockets reusable, cheaper, more reliable, to make them a more everyday vehicle. And if you think of any of the vehicles you use in your life, bicycle, car, airplane, you don't throw any of them away at the end of the journey.
Yeah. You just refuel them or clean them, and they're ready to go.
Exactly. You'd be crazy to do so as well, because you'd have to buy a new one each time. It would be insanely expensive. So that's the theory behind it. And that landing.
Brendan, how fast are they now in restarting with the same rocket? Is it like?
I think the aim is to refly them within 24 hours.
Yeah.
But I think the closest they've gotten to that is like 90 days. There was a 60-day. There was a 2-month turnaround on one of them. But they've also done reflights of individual rockets multiple times now. So the most accomplished rocket in the fleet at the moment has flown 6 times. And I think that one also holds.
It's pretty reliable for a rocket flight. That's pretty reliable, yeah.
Well, the aim for the Falcon 9 anyway is to turn around 10 times before they need to refurbish or replace any major components. So they're working towards that, but at the same time now they're building the vehicle that will be the backbone of the Mars colonization effort, and they're doing that in just as unprecedented and like a sort of crazy way as they've done everything else. In December 2018, images started appearing from a site that they had bought back in 2014 in South Texas, just on the border with Mexico, just at the seaside. And that site had been sort of more or less dormant for a long time. They'd been laying concrete and packing the ground and stuff, but nothing major or exciting was happening there. And then this metal cylinder appeared there, and people were saying, "Oh, it's a water tower. It's a water tower." Then it was equipped with a nose cone and flight thrusters and stuff, and people were like, "Holy crap, this is a development vehicle!" And it was a prototype for a Starship, which is what they're calling their interplanetary rocket. And it was just the craziest thing, because they literally got a water tower company to come out and just build this metal cylinder for them. They had been intending to build Starship using carbon fiber, go very, very high tech with it. But when they actually crunched the numbers, they found that carbon fiber gets very heavy when you put enough insulation on it to survive re-entry in the atmosphere.
Mm-hmm.
And the strength profile is pretty good, but steel is almost as good. And steel is actually lighter for the thermal properties of it. So they ended up realizing that steel is super cheap and works almost as well as carbon fiber. So they're building the ship out of steel now.
Nice.
And since that time in 2018, by September 2019, they had a prototype rocket fully built.
Mm-hmm.
Well, the spacecraft part of it, because this thing is going to be enormous, 9 meters in diameter. The spacecraft itself is something like 60 meters tall. The booster rocket that it sits on top of is another, spacecraft is 50 meters, booster rocket is 70 meters. So altogether, it's just under 120 meters tall. Now, they haven't built any boosters yet, but the spacecraft itself, like when you think of spacecrafts now, you've got the Soyuz module, you've got the Dragon capsule that SpaceX just started flying, having talked about. But those are like 3-person, 4-person, 5-person capsules. Even the space shuttle, which is a pretty big vehicle, max occupancy was like 9 people. The Starship has the same interior volume as like a 4-story house or maybe a small apartment building. And you can outfit that with if you pack people in, you can get tens or potentially like 100 people on a single flight of these things.
Wow. And tell me, Brendan, how far away in the phase where we're now, how far away are we actually from the first foot being set on Mars?
So Elon Musk made a bet with somebody, I think it was like a $1 bet or something, back in about 2010, that he would get someone on Mars by the end of 2025. I don't know that that's going to be doable. I'd say it's not impossible. It could happen, but I'd say we're probably looking at more like 2028 maybe.
That's not that far away.
No, not at all.
Not that far away.
And what we will see before then, probably in the next 3-4 years, is boots on the moon again.
Nice.
Certainly using a Starship as a lander.
There was a conference in Berlin last year where we had the HR lead of recruiting from NASA, and she did a speech, and the night before we had lunch together with the team, and she said that they're aiming towards that again, and that everyone's excited about that one. So yeah, I'm personally looking forward to both of these projects, and I think it's an extremely interesting thing, like just having the idea that we're multiplanetary, all those computer games that we used to play kind of come to mind, and like really interesting concepts come to mind.
Well, to me, it's the beginning of Star Trek. You know, it's that future, and sometimes it's difficult to hope for, you know, a future of united and peaceful humanity, but when you see things like this happening, it really fires me up. I really kind of feel like it might be possible.
Tell me, how can people who I always like to phrase stuff as people who first hear about this now, how can someone who first heard about Tesla or going to Mars and thinks that it's impossible, right now through this podcast they learn that it's very much so possible, and we're getting closer and closer to it. How can someone share that appreciation for it? And what do you think will be the biggest impact on people that are kind of like, just like not paying attention to it? Like what's the practical use and value of all of this?
Okay, I got you. Well, I mean, just on the rocket side of things, one of the biggest practical impacts that we're going to see very soon is Starlink. So this is an internet satellite constellation that's going up, and it's going to have super low latency and provide coverage for pretty much the entire planet with thousands of satellites in orbit. They're being launched all the time. In fact, most of SpaceX's launch this year have been Starlink launches. There's one on the pad right now waiting to go. It was supposed to go up yesterday, but they had to postpone that because of weather concerns. But they have launched, I think 11 or 12 rockets with 60 satellites on each rocket. So there's hundreds of satellites already up there, and they're aiming to put tens of thousands up there over the course of the program. And that'll just provide super fast, super available internet for the entire world. So that'll be the first kind of big impact that we'll see from this particular space program. And of course, that'll be very profitable for them, and they're going to plow all of that money back into the development of their Mars program. In terms of the other technologies that you mentioned, self-driving cars are just going to make our roads much, much safer. The electric vehicle revolution is already well underway, and that's going to improve the air quality, particularly in cities, but just generally as well, and hopefully make some dent in the horrible catastrophe that is climate change.
Yeah. I think we need to still work on that one.
Sure.
I look forward, I had an epiphany, when people first wanted to go to space, they made a bunch of inventions. They were kind of based on the atom bomb, and then they were used in the space program. And then they made their way into the kitchen, like the microwave is one of those inventions, or what was it, clinch film as well, and a bunch of stuff that we use as normal now were basically top secret projects that were used for the space program to make it easier for astronauts in extreme conditions. I'm sure that we'll get a second wave of those products in the next few years as scientists
100%.
figure out more things.
One of the goals of Mars colonization is to alter the environment on Mars to be more Earth-like. And
terraforming.
You can bet that through the process of terraforming, there will be payback technologies that will help us to correct the mistakes that we made here on Earth.
Yeah, definitely. Brendan, for the last part of the podcast, I always like to end on a kind of motivational note to leave kind of a cool finish for the people still listening to the end. Do you have some final words for people listening, something that might help people, or something that you would like to send out to the universe for as your own words?
Yeah, well, I mean, obviously from the way I've been talking, you can tell that I'm really fired up about space and space exploration, and particularly at times like now when we've got the world in the middle of a massive pandemic, we have really, really crazy and unstable politics going on all over the planet. This is something that you can feel pretty much unequivocally good about. It's something that is striving towards the future. It's not getting bogged down in all the problems that we have now, and it's looking at what we can do to forge a better future. And it's so exciting, particularly following the development of the Starship down in Texas, because they're doing that in such a public way. They're just doing it out in a field almost. Particularly early on, they were just assembling spaceships in a field, and not in a clean room or in a giant facility that costs billions of dollars, but in a field and welding it. And people are down there. There are people who have made their careers now out of
just filming and posting
cameras.
stuff. Yeah. Just
streaming, summarizing. There's weekly reports from multiple different YouTubers. Might as well list them out. There's What About It. There's Space Eccentric. There's Tim Dodd, the Everyday Astronaut. Tim Dodd is a brilliant resource because he's got a unique way of kind of breaking things down into easy to digest and understandable language, and before you know it, you're almost a rocket scientist. Listen to this guy. He was a guy who was a wedding photographer, and he got a spacesuit as a joke to take some photos. And people started asking space questions. And he thought, oh, I better look it up.
Yeah.
So he did. And now he's an expert. Now he's like Elon Musk's best friend on Twitter. So, it's an exciting, optimistic thing to be interested in. So if you need something like that in your life, I think it'll be hard to do better.
Awesome. Brendan, thank you again for being here. I know that we had some technical difficulties during this podcast. So if you would like, I would like to use this opportunity to invite you to a second podcast that we can do maybe in a month or two, where we probably won't have disturbances like that and make it a lot better. Yeah, let's hope so. But definitely, we just barely scratched the surface, and you and me are like that. We can just go into chats for hours. So yeah, if you want, we'll do another one again. And
yeah, I'd love to do a deep dive on one of these topics.
Definitely. I'll also leave a link to your channel at the bottom, so people can see what you're doing. And
not a lot.
Well, we'll see how it goes anyways. And yeah, thank you again for taking the time. Thank you for being here. Thank you for sharing all this information with everyone.
No problem. Thank you very much for the opportunity. It was really great to get the invite, and I'd be very happy to do it again.
Awesome. Thanks everyone who's still here at the end of the video. I know it was a little bit longer, but I hope you liked this podcast and the video. Make sure you subscribe to the channel. Leave us a comment. We would love to hear some feedback from you guys. Like, how did you like it? What do you think about these topics? What are your thoughts on the technologies that we discussed and how this whole situation is evolving and how it will evolve? And yeah, I will see you in the next episode.
The Uncle Gold Podcast.